Alright, Northern Oklahoma College, this is College Algebra, Math 1513, Chapter 1, Lesson 4. We're solving rational equations. Now, what is a rational equation? A rational equation, to me, is something involving fractions where we have a denominator that we have to worry about. Now, what do we have to worry about? What's weird about a denominator is it can never equal 0. Why can it not equal 0? Because we can't divide by 0. So if this denominator or this denominator turns into a 0, that would require that we divide by 0, and we can't do that. So we need to make sure we know when the denominator turns into a 0, because that's no good. Alright, so before I even start trying to solve this equation, I'm going to find when the denominator, which is x minus 2, equals 0. I need to find out when that happens. I got to know which number is the bad number. Now over here, my other denominator is also x minus 2 equals 0, so no need to work it twice. We're going to get the same answer twice. So I'm going to work this one right here. I add 2 to both sides, and I find out that x equals 2. Well, what I've actually found out is that x can never equal 2, because if x equals 2, look back up here. If x was a 2, then 2 minus 2 would give us a 0 in the denominator, and that would force us to divide by 0, which we can't do. So, whatever solution we come up with, we have to remember that 2 is not one of the solutions. The solution can never be 2. So I usually start by writing it above the problem that x cannot be 2, so I know which values are no good. Alright, so here's our problem. Now remember, I like to write these with a little space after each term, because we're getting ready to multiply every single term by the denominator, or rather the common denominator. Remember, that's our trick for solving these equations. Now it might help if you kind of group everything together. Alright, so there's my groups, there's my fractions. The common denominator, I have an x minus 2 over here and an x minus 2 here, so our greatest common denominator is x minus 2. So I'm going to multiply every single term by x minus 2. That's our trick for getting rid of fractions. We hate fractions, they're hard to deal with. So to get rid of fractions, we multiply everybody by the common denominator. Now this first one here, if you want to go ahead and extend this line, that's not a problem. And then we cancel, and have x plus 4. See? The fraction goes away. Look how easy that is. Here I'm going to do a little distributive property. Everybody gets multiplied by 3. And I have plus 3x and minus 6, because positive 3 times negative 2 is negative 6. Then my equal sign. Now over here, if you want to go ahead and extend that fraction line, if that looks better to you, cancel your x minus 2's. And you have negative 2, and all the fractions have gone away. The rest of it is just algebra, and you guys, I think, know this by now. You put your x's together, and we get 4x. And you put your whole numbers together. A plus 4 and a minus 6 is a minus 2. Then we add 2, and we get 4x equals 0. And divide each by 4 to get rid of that 4. And x equals 0. Now, when I say check, I mean a couple things. I mean, plug it back in and see if it works. So you would go back to your original equation and plug it in and see if it works. But I also mean check to make sure it's not the bad number. Remember, our answer could not be 2. Now this checks out. It's not 2, so 0 is probably a good number. We just need to plug it back into the equation and make sure it works, and we're done. And here's an example for problem number 15. It's a rational equation because we have fractions that we're dealing with. And when you have fractions, you have to worry about your denominators. So we need to know when does t minus 4 equal 0, because that's bad. So let's work it out. T minus 4 equals 0, add 4. T equals 4. But what's that mean? That actually means t cannot be 4. Alright, that's important. So remember that. and I'd put that above the problem. T cannot equal 4. So now we're going to go ahead and work out the problem and see what our answer is. And here's our problem all spread out because we're getting ready to multiply it. I'm going to go ahead and group our terms in the denominator. It just looks better. So I'm going to multiply this by t minus 4, and this by t minus 4, and this by t minus 4. I'm going to go ahead and extend the fraction bar and extend the fraction bar. That just looks better to me. Cancel, cancel. C, do your distributive property again. We're going to distribute, plus 3t minus 12 equals, cancel, cancel, 4. Put your t's together, we have 4t minus 12 equals 4. Add 12 to both sides. 4t equals 16. Divide by 4, and t equals 4. So all is well, right? Life is good? No. Why? Because you remember, way up here, t cannot be 4. That is the one number that won't work. So I'm going to put t cannot equal 4. So what is our solution? If we worked it all out and came up with 4, but 4 is not allowed to work, what is our solution? We have no solution. There's no number that will work. Okay? So don't put t equals 4. You have to understand that 4 does not work. And since 4 doesn't work, nothing works, so there's no solution. All right, what if you have more than one denominator? Like we have an x minus 1 here, and we have an x plus 7 here. So we have two different types of denominators. There's another x minus 1. We're just going to ignore it. We've already covered it here. So if you have two denominators, well, how do I get a common denominator? A common denominator, if you think back to like grade school, sometimes when I had to get a common denominator, I just multiplied the two denominators together. In this instance, a denominator of 3 and a denominator of 4, I could just multiply them together to get my common denominator of 12. And then you guys know the rest. I multiplied these both by 4, multiplied these both by 3, and I got 7 over 12. Okay, you guys get the idea. That's an oversimplified example of what we're getting ready to do. To get a common denominator, sometimes you just multiply the two denominators together. Okay, before we get started with that common denominator, remember we have to ask ourselves the question, when does that denominator equal 0 or that denominator equal 0? So we solve these, and x equals 1 and x equals negative 7. But remember what we mean. We mean x cannot be 1 and x cannot be negative 7. That's our note before we start our problem. X can't be 1 and x can't be negative 7 because that would turn denominators into 0, and that's bad. We can't divide by 0. All right, so let's try this problem now. Now remember our common denominator was x minus 1 times x plus 7. So I'm going to multiply every single term by that. We had our first term, our second term, then we had our equal sign, and we had that term afterwards. So each one of those is going to get multiplied by that common denominator of x minus 1, x plus 7. We're going to do that for each one. All right, and now we're ready to go. Let's see what we can cancel. I'm going to use red for the canceling. Cancel, cancel. Cancel this x plus 7 and that x plus 7. Cancel this x minus 1 with that x minus 1. What do we have left? We have 4 times the group x plus 7. And we have 7 times the group x minus 1. And we have 5 times the group x plus 7. Alright, that's what makes multiplying by that common denominator so cool. It changes these nasty fractions into just all whole numbers. And this we can deal with. Alright, next we just get rid of the parentheses. How do you get rid of the parentheses? By multiplying. A little distributing there. Distribute the 4, distribute the 7, distribute the 5, and we get it all multiplied out, and it looks like that. Now we look for like terms. Here's an x term. Here's an x term. Remember to keep your sides of your fence separate. Putting together the x terms, I get 11 x's. And then I look at my whole number. Putting a 28 and a negative 7 together gives me a 21. And it's a positive 21, so I write plus. Plus and positive mean the same thing. Over on this side, we have 5x plus 35. And we've talked about how to do this. I usually get rid of the lower x. Gives us 6x plus 21 equals 35. Minus your 21, you guys know all this. 6x equals 14. And divide your 6. And x equals 14 over 6, which we're going to reduce to 7 over 2. Remember, check. Okay, that means not only put it back into the equation, but remember our rule. We said x cannot equal 1, and x cannot equal negative 7. Well, that's fine. We check that, and the only thing left to do is run it back through the equation and make sure it works. Oh, and one last thing. Let's reduce this correctly. Splitting those in half is 7 over 3, not 7 over 2. Oops.